So let's look at some more complicated substitution problems. Like this one, the integral of x squared plus 2x over x plus 1 squared dx. And if you look at this x plus 1, it's inside a larger x plus 1 square. So one obvious thing to do is to let u be equal to x plus 1. And so that would mean that du dx is, that's 1. So that means dx is equal to du over 1, or dx is du. So if you look at this, well, it doesn't actually help us in terms of the numerator, because usually, things cancel out when you do a substitution. Here it doesn't, because, well, du dx is 1. 1 doesn't cancel anything out. So we're gonna have to do a little more algebra here. And so this is now a problem in u. These x's up in the numerator, they don't really belong anymore. So we can get rid of them by using this equation here, u equals x plus 1, or x equals u minus 1. So this is actually integral of u minus 1 squared plus 2u minus 1 over u squared du. It looks worse than before, but it is actually much better than before. If you just expand the top, that would be u squared minus 2u plus 1 plus 2u minus 2 over u squared. The minus and plus 2u's cancel each other out, du. So this is the integral of u squared minus 1 over u squared du. And now, because we only have one thing in the denominator, see back here, we had this big x plus 1 squared in the denominator. We couldn't really do anything with it. But now that we have only u squared on the bottom, we can separate this into u squared over u squared minus 1 over u squared du. This is just 1. And 1 minus u squared is u to the minus 2. So the integral of this would be u minus u to the minus 1 over minus 1. See, these minuses cancel each other out, so it's just u plus u to the minus 1. And remember now that u was x plus 1, so we could just replace u by x plus 1 and get x plus 1 minus 1 over x plus 1 plus c. And if you want to combine these, go right ahead, but this is essentially the calculus part. Next, let's look at cosine root x over root x dx. Once again, it's a little obvious here that since the root x is inside a cosine, we want to let u be equal to root x. And so du dx is equal to 1 over 2 root x. And so dx is du over du dx. That would mean that dx is 2 root x times du. When you first look at this problem, it looks like the root x is in the denominator. Usually we get dx is du over something. Well, it won't cancel out, but actually sometimes it does, because sometimes the derivative of u is kind of a denominator. In any case, let's plug everything back in. So we have the integral of cosine u over root x times 2 root x du. The root x's cancel out. This is the integral of 2 cosine u du. And so that would just be 2 sine u plus c. And since u was root x, this is 2 sine root x plus c. That's the antiderivative of cosine root x over root x.